Now let's take our first example. They say the velocity time graph below represents the motion of a girl riding her bicycle in a northerly direction, right? So they've told us in this case that we are headed northwards, right? So now let's answer the couple of questions that we are given here, right? So firstly, let's analyze what's happening on this graph, right? So when the story began about this girl, can you see that our velocity does not change between A and B, right? So it tells us she's moving at a constant velocity, right? Between A and B, her velocity does not change with time. But look at this. Once she gets to B, she starts accelerating, right? Her velocity is increasing with time. So in this case, this is a positive acceleration, right? Right, she is speeding up, okay? Or we can say she is increasing in velocity. And then what happens again? Between C and D, right? Let me just increase there a little bit. Right, so between C and D, she is now at constant speed yet again. Okay, so her speed is constant and now she is not changing. However, her speed or her velocity is much bigger than it was initially, right? So her velocity there, if we have to follow the trail, is at 10 meters per second. She started with a velocity, let's see from our graph, so that's 4 there. It looks like it's increasing in twos, right? So that's 2, 4, 6, 8, 10. So that looks like, actually, I'm saying it increases in twos, but if we note this, okay, so this is between 4 and 2, right? So which means in this case, this is midway between that. So that means that is 5. So her velocity was 5 initially, right? So this is actually, yeah, so this is 4.2, 4.4, 4.6, 4.8, and that's 5, right? It's actually increasing in 0.2 in that case. And then what happens between C and D? She now decreases in velocity until she eventually gets to this point. And what happens at that point? The velocity is 0, right? So, which means she eventually stops at C. Okay, so we have to be able to tell what is happening in the picture so that we can answer the questions, as adequately as possible. Right, now let's go to the questions. So they ask us the question. They say, write down the girl's initial velocity. Notice they say write it down, which means we didn't have to calculate it. And we've said that her velocity is 5 meters per second, isn't it? So her velocity is 5 meters per second. Right, now to the next one, they say write down the magnitude of the girl's velocity at 300 seconds, right? So at 300 seconds, let's check. Now we are looking for what we call the instantaneous velocity. So meaning the velocity at that specific moment, right? So there's our graph over there, right? It seems like it ends there. Okay, so her velocity must have been, it looks like, so this is 8 over here. So it looks like 8.2, right? Remember we said they are increasing in twos, in 0.2s, right? And how can you tell that, right? So what you do is you take the difference between your major lines, right? And you divide it by the number of lines that you've got in between. So 2 minus 0 gives us 2, right? There are 10 steps in between. So we're going to divide by 10 and that gives us 0.2. So it tells us we've got 0.2 per step, right? So in this case, we have 8 at that point there, and it goes one step up, so that that now becomes, well, look, I think it edges between 8.2 and 8.4. So I'll just say 8.4. Okay, right. So we know that a velocity at 300 seconds was 8.4 meters per second. Now they say use the information on the graph to describe the motion of the girl from B to C, right? So what's happening from B to C? We said she is increasing in velocity. She's increasing from a velocity of 5 meters per second to 10 meters per second. We can also say that she is accelerating, right? So she is increasing in velocity from 5 meters per second to 10 meters per second. Okay, you can also say that she is accelerating northwards, right? She is accelerating northwards, or you can say in the northerly direction, right? From 5 meters per second to 10 meters per second. Please remember that makes a difference. You know, we are stating the direction in which she is accelerating. Right, and then the next question, they say to us, from C to D. Now notice she moves at constant velocity of 10 meters per second. So we can say that she is moving at a constant velocity of 5 meters per second, actually of 10 meters per second, right? Of 10 meters per second. You don't need to necessarily specify. You can just state that she is moving at a constant speed or constant velocity. Right, now they say without using equations of motion, meaning we ought to use the graph in order to answer the questions now that are going to follow. They say calculate each of the following, right? The distance covered by the girl from A to C. Now I want you to remember, ladies and gents, that when we said, right, when we were looking for for position or for displacement, right, under a velocity time graph, we said we are going to use the area underneath the graph. Now, you have to be mindful of the shapes that you have inside your graph. So I'm going to take, well, first of all, from A till B. They said we need to take from A till C, right? Meaning we want to find out what is the displacement from A till C. So I've got what looks like a rectangle there, and I say a rectangle because I know some of us would have said a square. Remember that our dimensions would not be the same, right? And then I've got a trapezium between B and C, right? So let me just use a different color. So between B and C, I've got a trapezium there, but you don't need to actually use that as a trapezium. What we will do, or what we can do, is just to divide that into a triangle, right? So this would be our triangle over here, okay? And we've got a rectangle below there, okay? I'm just trying to use different colors so that you can be able to see it, right? Sorry, they said till C. Yeah, they did say till C. And notice now what happens at C? In this case, the time there is 350. Okay, so that's 350 in terms of our time. Right, now let's look at between A and B. Right, we said that's a rectangle there. So for 4.1, right, it means that if we're looking at the distance, we're going to say the area of A to C will be equal to the area. I'll take the area from A to B, right, plus the area from B to C. Right, now let's start with the area from A to B. Right, so we said from A to B, we have that rectangle there. So it's going to be half of the length. Okay, let me just use a different color there. Right, so the length is 200 and the breadth would be, I think that's 5. Oh yes, it was 5, right? So that's 200 times 5. Okay, so I'm going to say, right, the area of A to B, that's going to be length times breadth. And the area from B to C, we said we've got a triangle, half base times perpendicular height plus length times breadth again. Okay, right, so in this case, let's start with the first one. We said that's 200 multiplied by the height in this case, or the breadth, which is 5. So that's 5 in the positive plus half times our base. Now we need to be very careful about the base, ladies and gents. Right, so let me just remove all of this. I hope you can see it. Okay, if you can't, I'll just use my highlighter. So this would be my base here, right? So if I look at my base, it's from this point, from 200 up until 350, right? Now, how big would that be? From 200 to 350, that would be 150. So it's this base over here, which is that base over there. But what would be the perpendicular height? So this is from 5. Remember, it was from 5 here, all the way up until 10 meters per second. So our perpendicular height for our triangle is 5. Okay, so that's 350, which is our base. Okay, and this is 5 for the height. So I'm going to say half base, that's 350. Remember, how did we get the 350? We said, sorry, that's 350 minus 200 rather. So half of 350 minus 200. Okay, and the height we said was from 5 till 10, so you can say 10 minus 5, okay? Plus, now we said we're going to also take another length times breadth. So notice, which one are we taking, right? We're saying, actually, let's put, okay, there's our height there of 5 again, right? And then in this case, or not the height, rather the length or the base, okay, the base would be again 200 to 350, which is 150. So, okay, plus 150, or you can say 350 minus 200, so that you know where we took that from. multiplied by the height. So the height is this one over there, and we already know that's going to be 5 meters per second, right? So that is how we're going to multiply or to get our area underneath the graph. So let's calculate all of that. So this is going to be 200 times 5, that's 1,000. Okay, plus, notice this is going to be 5 times 150 times a half. Okay, so let's do that. 0.5 times 150 times 5. This is 375. Okay, again, we've got another 150 times 5. Okay, which is 750. Okay, that's 1,000 plus 375 plus 750. This gives me 2,125. And notice, remember, we are dealing with distance, right? Covered between A to C. So that would have been in meters. So the distance would be 2,125 meters. Right, I hope this makes sense, ladies and gents. Right, as we go to the next one. Right, so let's go to the next question. They say calculate the acceleration of the girl from D to E. Right, so notice from D to E, the change, our velocity at D, or rather let's start with the time there. It looks like the time at D, remember, so we are increasing, right, by hundreds for the major line, and for each step you divide that by 10. So that means that 100 divided by 10, that gives us 10, right? So for each one we are increasing by 10. So notice this is 500, that's 510, 520, 530. This looks like 535. Okay, so that means the time is 5:35, and my height or my velocity was 10. But then we get to this point here, 600. Okay, so our time is 600 and our velocity is 0. So we're looking for the acceleration between DE, right? So we're going to say acceleration from D to E would be change in velocity divided by the change in time, right? So this would be the velocity at E minus velocity at D divided by the time at E minus time at D. Notice whatever order that I have at the top, I must maintain at the bottom, right? So the velocity at E, okay, this was 0, right? So remember, our velocity there is 0, and our velocity at D was 10, so that's going to be 0 minus 10. Divided by the time at E is 600, okay, and the time at D is 5:35. Right, so let's do that quickly. So that's 0 minus 10 divided by 600 minus 535. Okay, and we get an acceleration of negative 0.15 meters per second squared. Notice this acceleration is negative, but it is still heading northwards, right? So what does this tell us? That this is acceleration in the opposite direction, right? Or it is actually slowing down at a rate of 0.15 meters per second squared. Okay, right, now let's go to the next one. In fact, I'm just tempted to just say our acceleration is 0.15 meters per second squared, right, in the southerly direction. Okay, so southerly direction. All right, now let's go to the next question. They say to us, during which stages of the journey is the change in speed the greatest, right? Now, I want you to note, in this case, we're talking about a change in the speed. We changed from 5 to 10 between between B to C, right? But here we changed from 10 to 0 in a very short space of time, right? So this is where we experience the greatest change in the speed, okay? So I will say, well, during which stages, right, is the change in speed the greatest? It's during stages D to E. Okay? Right. Now they're asking us, explain the answer to question 4.5. Okay? So in this case, our velocity changed, right, from 10 to 0 within a very short space of time, right? Whereas here we change from 5, it's a smaller change in velocity, but over a longer period of time, that is between B and C. Now remember, A and B and stages C to D, right, that our velocity is constant there, so there's no change in velocity, right? So we experienced our greatest change. Okay, so let's answer that question. So we said 4.5, we said during stages D to E, and they said we must explain that, okay, right, that the velocity decreased. Okay, so our velocity decreased significantly over a short span of time. All right, so our velocity decreased, right, significantly over a short span of time. Or you can also mention the fact that we decreased from 10 meters per second to 0, right, over a shorter time than in B to C, right? And so, ladies and gents, that is really how we come to the end of this question, right? Of course, there were so many other things that they could have asked. They could have asked the total distance of this, whatever of the scale that she has covered. Of course, we would have taken the area underneath the entire graph to calculate that. But that is essentially how we answer questions on velocity time graph. Okay, so in our next video, we will be looking at the position time graph, right? I hope that you were able to understand this. And of course, if you still are struggling with mathematics and science, right, please make it a point that you look at the description of this video, and all our details and information will be found there, and we will gladly assist you in anything that you need in maths and science. Otherwise, ladies and gents, it's been a pleasure to be with you. I'll be with you again next time. Shap shap.